Okay, just do them one step at a time, okay? I'll write it here. Do them one step at a time. Okay, this can make you make fewer mistakes. Okay, next, just follow the order of arithmetic operations. Follow the order of arithmetic operations. Okay, that means if you have brackets, calculate anything in the brackets first, and then multiplication or division, and last addition and subtraction, right? Follow the order of arithmetic operation. And when necessary, use formulas such as what you have already know, that a squared minus b squared is a plus b multiplied by a minus b, or a plus b at a whole square is a squared plus 2ab plus b squared, right? So if we change this sign to minus, you have a minus sign here. So the third step is, when necessary, you can use formulas like this. Okay, so let's have a look at these questions. The first one, okay, if you think it's a complex expression, just as I said, do them one step at a time. Okay, let's do this one first, and just follow the order of arithmetic operation. So the first term is actually 3 by 3 over square root 5, right? And times, copy this number here, and divided by the next number. Next number is actually minus 2 times square root 12 over 3, right? This is your first step. And after that, because you only have a multiplication or division sign here, so in the next step, we can cancel something, right? Root square 5 can be canceled with root square 5. Anything else? There's a 3 here. Sorry, 3 cannot be canceled with this one because this is a division sign here, right? So just leave it there. Okay, the next step, 3 square and then square root is 3, right? Times 3. Okay, divided by something is times its reciprocal, which is minus 2 square root of 12. 3 now becomes the numerator, right? Okay, next. We have 27 or 3 to the third orders divided by minus 2 times square root of 12 is 2 times square root of 3, right? Okay, next. we can, what can we do here? We can times the same number to the numerator and denominator. The ratio does not change, right? We can times a square root of 3 to both of the numerator and denominator. And then the result is, okay, I'll just write 27 here. 27. Okay, minus 2 times 2 times 3, right? And then you can see that we can cancel a 3 here, because 27 is 3 by 3 by 3, right? So both of them have a factor of 3, so we can cancel one. Okay. That means we divide both the numerator and denominator with a 3. So what's left in the numerator is 9 here. So the final result is minus 9 over 4 times square root 3, right? This is the simplest form of this expression. Okay, any questions? All right, let's see the next one. Okay, next one. First of all, by observation, this is a multiplication of two terms, right? And you can see that it happens to be a plus b times a minus b, right? A here is 4 times square root of 3. B is 1. So that means we can use a formula. Okay. Okay, by the associative law, we can change the order of these two items like this, right? So this is the first step. Second step, we can just leave it there. As I said, one step at a time. So next step, you have a plus b times a minus b. So according to the formula, this is a squared minus b squared, right? Okay, calculate this first, and then at the same time, now you can calculate the second part of the expression, which is by the formula a minus b to the second power, which is a squared minus 2ab plus b squared, right? So here we have 18 minus, you remember there's a square here. 18 minus 12 square root of 2 plus 4, right? Okay, next step, we have 16 times 3 minus 1, right? And what's left in the second bracket are 22 minus 12 times square root of 2, right? So next step, the first part of the expression becomes 47, right? And second part is minus 22 plus. Why is a plus? Because you have a minus here, right? Minus, minus, and then you got a plus sign here. It's plus 12 times square root of 2. Okay, so the final result is 25 plus 12 times square root of 2, right? So can you see why you make mistakes here? Okay, do think about it, because none of them are very complex. Okay, if you have any questions, do let me know in the class. Okay, I can explain them in detail. Okay, any questions? For Dora, I think the mistakes you did is you take the wrong sign, right? So basically, if you have an expression like a minus c minus d, what's the result here? This expression equals to what? Should be a minus. If you delete the brackets, it becomes a minus c plus d, right? Do you understand? Dora? Okay. So do pay attention next time, okay? Because sign is very important. Okay, next parts, question C. Okay, so, question like C here won't be a problem for you now because both of you have done this correct. Okay, so basically the result is, okay, if we have two numbers, a to the mth power times b to the mth power, the result is a times b and brackets to the mth power, right? So this is a rule we're going to use in this question. So the first part of the expression is a sum to 2021, which can be rewritten as the sum of these two numbers to 2020 times 1 time of this sum, right? And then times the sum the sum of these two numbers to 2020. Okay, why can I call this a sum? Because this is actually square root of 6 plus minus square root of 5. Actually, it is also a sum, right? So we can also call it the sum of these two numbers. And then it becomes, okay, according to the commutative law, we can put this term in the front, right? Commutative law says we can put this number in front. And then times this one times this one. And then because we have three numbers multiplication, according to the associative law, we can calculate the second part first, right? So this becomes this number times, okay? According to the rules here, this is, you can calculate the multiplication of these two numbers first, and then the result as a whole to 2020 times, 2020 order, which is 1 to 2020th order, which is 1, right? So the final result is square root of 6 plus square root of 5. Okay. Second part is about rewriting the expressions as a single fraction and simplify. Okay, so first of all, let's recall what are the common steps. Okay, first of all, before you start to calculate each expression, do remember that you can use associative law, commutative law, and distributive law flexibly. Okay, I'll write it here. Use associative property or commutative or distributive property when necessary. Okay. And second, find the least common denominator. Oh, sorry. The second step should be follow the order of arithmetic. Follow the order of arithmetic operations. Again, that means you calculate anything in the brackets first, and then these two, and then addition and subtraction, right? Okay, that means if you find anything is complex, do remember to do them one step at a time. Do not try to do multiple steps at a time, because in that way, it's easier for you to make mistakes. Okay, and then you can then find the least common denominator. Last, we can then simplify if necessary. Okay, so follow these steps. Let's see the first one. Okay, first one, you can either treat these two as a whole, right? Or if you can also treat them separately. Both of the two ways can do. Okay, let's see the first one. If we treat these three terms separately, okay, so what's the least common denominator? Apparently it's x minus 3, right? So if you rewrite the first term, okay, I'll write one more step for you. This is actually x over 1 plus 3 over 1 plus 5 over x minus 1, right? So the least common denominator is x minus 3. So if you rewrite all the terms, use x minus 3 as the common denominator. The first terms becomes x times x minus 3 divided by x minus 3, right? Second term becomes 3 times x minus 3 divided by x minus 3, right? Because when you times a same number to both the numerator and denominator, the ratio keeps unchanged. Understand? Okay. Copy the last term here. Right. Next, because all of them are using the same denominator now, so we can add the numerator together. Okay. First one is x squared minus 3x. Second one plus 3x minus 9, right? And plus 5. So this becomes x squared minus 4 over x minus 3. This is the final result, right? Any questions? No? All right. What's the problem? Oh, I see. No question, right? Okay. Okay, second way, as I said, you can also treat x plus 3 as one term, right? If you treat this as one term, you get x plus 3 over 1. Plus 5 over x minus 3, right? So in this way, the least common denominator is also x minus 3. And then if you rewrite the first term using x minus 3 as denominator, what is the numerator now? X plus 3 times x minus 3, right? So just copy the second term because it already has a common denominator. So what's the next step? Because both of them are using a common denominator, so you can add them up, right? Denominator is x minus 3. First term, you can see the formula again here, right? A plus b times a minus b, which is a squared minus b squared, right? So the result here is x squared minus 9 plus 5, right? Okay, minus 9 plus 5 is x squared minus 4. Then this one over x minus 3. Okay, you can either leave it here or rewrite it in this way. It doesn't matter because it cannot factor anymore, okay? So this one and this one are both okay, right? And for Dora, I think your problem is you don't know when to cancel the terms. Okay, I'll write your steps here and explain this to you. Okay, this is your solution, and I can see there you try to cancel these two terms, right? Okay. When you cancel something, what do you cancel actually? If you want to cancel x minus 3, actually, you are doing this, right? You times both the reciprocal of x minus 3 to both of the denominator and numerators, right? So in this way, these two can be canceled with each other. This one can be canceled. And remember that according to the distributive law, you will also be cancel x minus 3 here and here, right? Understand? So you can't just cancel one x minus 3. Okay, I'll set you another example. For example, you have an expression like a plus b minus c divided by a. Okay, you can't just cancel a here. Understand? Because when you want to cancel an a, actually what you do here is to times the reciprocal of a, both of the denominator and numerator. In this way, only this way, you can cancel a here, and the denominator becomes 1. So what is the numerator here? It's 1. Okay, according to the distributive law, it's 1 plus b over a minus c over a, right? It's not just cancel a here. Okay, do remember that before you cancel or simplify something, you put them in a product form or factored form. Okay, I'll just write it here. Before canceling, rewrite both numerator and denominator in factored form. What does this mean? Factored form means a product. Okay, for example, if we have a product form A, B, C, and A here, or A, B, both of the denominator and numerator are in a factored form. In the product, it's a product, right? And then in this way, you can cancel these two, right? But if they are in a form like this, you can't just cancel these two. Understand? Okay, similarly, if you have two terms like this, as you can see here, this is a product of a plus b and a minus b. And a plus b can be canceled with a plus b in the denominator, right? Okay, so I think you are still a little confused about the rules of canceling. So make sure you transform both the denominator and the numerator in a factor form, okay? What you are canceling is actually their common factor. Okay, I'll write it here. You are canceling the common factor of numerator and the denominator. Okay, you need to find their common factor and cancel the common factor. Okay, all right, next question. Actually, the rules are the same, right? Okay. Okay, follow the order of arithmetic operation. Okay, you can see brackets here. So let's calculate this part first. Okay, in order to calculate this part, we need to write them in a common denominator, right? So the common denominator is x plus 2, right? Okay, I'll write one more step for you, okay? This is the first part of the expression. And this divided by something is multiply the reciprocal of this expression, right? Okay, then now we calculate the first part first. Common denominator is x plus 2. Then the first term becomes 2x plus 4, right? Minus this one. Okay, next, first two terms can be added together to 2x plus 4 minus 4. Plus 4 minus 4 cancels with each other because 4 minus 4 is 0, right? So what's left in the first part of the expression is 2x over x plus 2, right? So the second part, in order to simplify, it's better to rewrite the term in a rewrite this term in a factored form, right? As I said, before canceling, rewrite both numerator and denominator in a factored form. In a factored form, okay. So x squared minus 4 is x plus 2 times x minus 2, right? Because we are using the formula that a squared minus b squared is a plus b times a minus b, right? Okay, so here, now the numerator is in a factored form, which means now it's a product, right? A product between x plus 2 and x minus 2 over x squared. Okay, x squared is already in a product or factored form. It's product of x and x, right? So next, you can try to cancel anything there, okay? X plus 2 can be canceled with x plus 2 here. And x can be canceled with x here, right? So the final result is 2 times x minus 2 divided by x, right? This is our final result. Now, do you have any questions? Okay, you can also write final result in this form. Doesn't matter because it cannot simplify any further. Okay? Any questions, both of you? Okay. Next one. Okay, following the same rules. There are only two terms, right? Okay, so in order to find the least common denominator, it's better to factor each denominator, and then it becomes easier for you to find the common denominator, right? So the first step is to factor the first denominator to x plus 3 times x minus 3, right? Okay, keep the second term unchanged. Now we can see that the least common denominator is x minus 3 plus, minus 3 times x plus 3, right? Again, we're using this formula here. Okay, so the next step is to rewrite both of the terms here using the common denominator, because only in this way you can add these two terms together. Okay, keep the first term unchanged the second term, we time x plus 3 to both of the denominator and the numerator, right? Okay, next, now we can do the addition here. Okay, rewrite them in the common denominator. First term, 3x minus x times x plus 3, right? So this is, and then we can try to expand the numerator. Why do we need to expand the numerator now? Because it's probably that you can cancel something in the numerators and then factor the numerator again and then cancels with the denominator again, right? So here, after the addition operation, then you expand the numerator. And now you can see that 3x minus 3x is 0, right? So these two terms are gone. And the final result is minus x squared divided by x plus 3 times x minus 3, right? Can you see this? Okay, any questions here? No? All right, let's see the next one. Okay, next one. First, there are brackets there, right? So usually we'll follow the orders of arithmetic operations. If there are brackets, let's calculate this part first, okay? Just copy the first part unchanged times, okay, what's left there? Apparently that's 1 over 1 plus 3 over a minus 1, right? Okay, so apparently the common denominator of these two terms is a minus 1. So here, copy this term times a minus 1. Okay, let's do this slowly, okay? Because most of you have done this incorrectly, so let's do them slowly. One step at a time. Okay, 1 over 1 over 1 over 1. 1 minus 1 over a minus 1 over a minus 1, right? So second term is 3 over a minus 1. Okay. First part unchanged. Second part now becomes a minus 1 as a denominator. And what is the numerator here? It's a minus 1 plus 3, right? Which is a plus 2, right? Okay, now you can see that because you have a multiplication sign here. So first of all, you can cancel these two terms, right? Because when you have something like this, it's always feasible you can cancel the triangle here because you have a multiplication sign. If it's a plus sign, you cannot do this, right? Okay. And now this becomes a squared minus 1 times over a minus 1, right? And then according to this formula, a squared minus b squared is a plus b times a minus b. So we can factor this into a plus 1 times a minus 1 over a minus 1, right? So now you can see that both of the numerator and denominator are in a factor form, or both of them in a product form, okay? So for the numerator, it's a product between, it's a product of a plus 1 and a minus 1. For the denominator, is a minus 1 times 1, right? Both of them are in a factored form. So now we can cancel a minus 1, which leaves us a plus 1, right? So a plus 1 is the final result. Okay, do you have any questions? No? All right, let's see the next one. Next one, you see brackets, so let's calculate this part first. Okay, copy the first term divided by, okay, first term is x over 1 times minus 4x minus 4 over x, right? So the least common denominator is x. So here we have, okay, copy the first part, divided by, okay, rewrite the first term using x as denominator, and the numerator becomes x squared, right? Okay, one step at a time, divide it by, now we can combine these two terms, right? So x in the denominator, okay, for numerator, that becomes x squared minus 4x. And pay attention to the sign here, right? Minus minus, you have a plus 4 here, right? Do not confuse the sign. And then you have x plus minus 2 over x divided by, and now you can see we're using this formula, which is a squared minus 2ab plus 2b squared is a minus b squared, right? So now here a is x, b is 2, right? So here we have x minus 2 to the second power over x, right? Okay, now we have x minus 2. And you can see here, the first part of the expression never changes. I just copy them in each step, right? Because as we said, it's better for you to do them one step at a time. This can make you less likely to commit mistakes. So divided by something is multiplied by the reciprocal of the term, which is x minus 2 brackets to the second power, right? And x here. And now you can see that, first of all, you have a multiplication sign here, right? And second of all, both of the two terms are in the factored form. That means they are both a product of something, right? Now you can cancel x here and x minus 2 here. So the final result is x minus 2 in the denominator, and only have a 1 in the numerator. Okay, understand? And for Dora, again, I think you confuse this signs. Okay, when you calculate a minus b minus d, be careful that if you expand this expression, you will get a minus b plus d. Okay. For Emily, I don't know why you make a mistake here. Is it because of carelessness or something else? Because when you calculate x minus, you get, Emily, are you there? Okay, I don't see the reason why you calculate. When you calculate this expression, you get x squared minus 2x plus 1. Okay, apparently this is not the right result. Okay, it should be x squared minus 4x plus 4. Okay. So do you have any questions here? I don't see why you do this like this. Hello? Okay, both of you, any questions? No, really? Okay, because I think considering your performance to this assignment, I think we better practice them again in the next assignment. I hope both of you will not commit the same mistakes in the next assignment. No question? No? All right, let's see the next one. F. All right. Normally speaking, we need to calculate this part first, right? And then find its reciprocal, and then find the multiplication between these two terms, okay? So just copy the first term down in the next step. We divide it by, all right. How to make the calculation easier? You can rewrite the expression as minus x plus 2, right? Do you have any questions to this step? Can you see why? Can you see why we do this? Because when you treat x plus 2 as a whole, it's easier for you to find the common denominator. Okay, so the common denominator here is just x minus 1. You don't have to do it 2 times. If you treat this x plus 2 as a whole, you only need to do once, right? So this becomes 2x minus 6 divided by x minus 1 divided by, okay, now we rewrite these two terms using the least common denominator. Okay, the second term now becomes x minus 1, okay, x minus 1 here times x plus 2, right? Okay, copy the first term, one step at a time. Divided by, okay, because both of these two terms are using the common denominator, so we can combine them together, which becomes x minus 1 as denominator. What's left up there is 10 minus, okay, what do we have here? Expand this expression, and it becomes x squared plus x, right? Minus x plus 2x is plus x, and minus 2, right? Okay, one step at a time. Divided by, now we can combine these. 10 minus x squared minus x plus 2, right? Okay. 2x minus 6, x minus 1 divided by, okay, what do we have here? Minus x squared minus x plus 12, okay, x minus 1. And then we need to rewrite this expression in a factored form. We need to factor it. How to factor it? Okay, some expression like this. We studied the method that is called cross product, right? First, we need to find a product of two numbers that is minus 1. Okay, this is apparently 1 times 1 is minus 1, right? So next time we need to find the product of 12. Okay, 3 by 4 is 12. And then after the cross product, sum of the cross product is minus 1. So now here we have 4 minus 3 is 1. So this is not what we want. So we can change the order to 4 by 3. And now minus 4 plus 3 is minus 1, which is the number here, right? So we can factor this expression as x plus 4. This is x plus 4 here, times minus x plus 3, right? Okay. That means 2x. Okay, 2x minus 6 can be rewritten as 2 times x minus 3. Okay, the reason we do this is that, again, we want to rewrite each term in a factored form. Okay, minus divided by x plus 4. Okay, minus x plus 3 is 3 minus x divided by x minus 1. Okay. And now you can see all of the terms are in a factored form. And we have a division sign. Next, we need to change the division sign to a multiplication sign. So that means we rewrite this expression as this one. Invert the denominators and numerator. x1 is here. X plus 4 times 3 minus x now becomes the denominator, right? Okay, now we can see that what can we cancel here? This is x minus 1 can be canceled with x minus 1, right? And x plus x minus 3, 3 minus x. There is if you cancel these two terms, they're left minus 1, right? So the final result is minus 2 over x plus 4. Okay, any questions? No? Okay. No question? Okay, next. Okay, next one, problem like this, we have practiced a lot, okay? First, try to factor this number. Okay, this number can be rewritten as 60 to the fourth order. So that means the original expression can be rewritten as 60 to the fourth order and then to the minus 3/4 order, which is 60 to the 4 by minus 3/4 order, which is 60 to the minus 3 order, which is 60 to the third order as denominator, 1 as numerator, which is 216,000. Remember, there are 3 zeros because we have a third order, third power here. Okay. And next one. Again, we have practiced the problem like this many, many times. Okay. First of all, let's see what we can do to the right-hand side of this expression. Right-hand side, first term is actually 3 to 1/2 times, 1/2 power. Okay, this number times 3 to the second power and then to 1/3 power times 3 to the third power and then to the 1/4 power. Okay. Again, you can further simplify the right-hand side to this number. Okay, this is actually 3, 1/2 plus 2/3 plus 3/4 power, which is 3 to the 23/12 power. Okay, so now you can see that 3 to nth power, if you are given that 3 to the nth power equals 3 to the 23/12 power, that means n is 23/12, right? Okay, any questions? Okay. Dora, I can see that you did not do this correctly. What's the problem here? Okay, I can see that you get to this step. So now yn is 1/4. How do you get n is 1/4? Hello, Dora. Are you still there? Yeah, yeah, I can see you get to this step, 3 to the nth power equals 3 to 1/2 times 3 to 2/3 times 3 to 3/4 power, and yn is 1/4. I don't see the logic here. Can you tell me why you get to this conclusion? N is 1/4 because 3 and 3 cancels out. 2 and 2. Oh, you do this like this. Okay, I see. All right, let me show you why this doesn't work. When you 3 to the 8th power times 3 to the b's power times to the 3 to the c's power, what's the result? Okay, let me show you another example. 3 to the 2nd power times 3 to the 3rd power times 3 to the 4th power. What's the result? Okay, 3 to the 2nd power is 3 times 3, right? Okay, 3 to the 3rd power is 3 by 3 by 3, right? 3 to the 4th power is 3 times 3 times 3 times 3, right? So what's the result here? You have 9 3s times together. The result should be 3 to the how many times? Hello, Dora. Are you following me? Okay. So what's the result here? You can just can you turn on your microphone? Why is 27? 27. No, I mean, what I mean is when you have 3 times 3 times 3 times 3 times 3 times 3 times 3, 1, 2, 3, 4, 5, 6, 7. This can be rewritten as what? This is apparently not 27, right? This is 3 to the 9th. 1, 2, 3, 4, 5, 8, 7, 8, 9. You have 9 3s, right? So that's apparently 3 to the 9th, right? Okay, so all right. As you can see that if you have 3 to the 2nd power, 3 to the 3rd power, and 3 to the 4th power, and you times them together, you have 3 to the 9th power, right? So 9 is a sum of 2, 3, 4, right? Okay, so now if I ask you 3 to the 8th times 3 to the b's times 3 to the c's, what's the result? It should be 3 to a plus b plus c's power, right? Okay. Actually, it should be 3 to brackets a plus b plus c. Okay. This is a rule when we compute the product of exponentials. So now, can you see the mistakes here? Okay, you don't time them together, you add them together. Okay, So n is not. This is not correct. N here should be equal to the sum of these three terms, okay? This one is correct. Okay. Please write this down in your arrow book. Okay. When you write this down in your arrow book, you should also make notes. Like if you do this, am times an. This is a to the how many times? M plus n, right? And am brackets to the nth. This is a to the m times nth. Can you see the difference? Okay, write this down besides this question, okay? And also, if you want to expand this, a to the m's power divided by n to the nth power. What is the result here? All right. Okay, write this here. Remember the brackets. It should be actually a m minus n, right? Should be m minus n. Oh, sorry. I speak to the wrong person. I'm talking to Emily all the time. Okay, I'll type it here. Okay, can you see my typing? Remember the brackets, okay? And also a to the m's and then to 1 over n's power. What is the result? What is the result here? Yes, that's a to the m over n's power, right? And sometimes we also can rewrite this expression as this form, right? Correct? Are we clear here? Are we clear? Okay, so make sure that you put all these formulas, all these rules, along with this question, okay? So next time, it helps you avoiding committing the same mistakes, okay? That's how you learn from your mistakes. I think I'll just leave it here. Okay, next part. Last part is simplified following expressions. Okay, again, I think you have done most of them wrong, so let's see them one by one. First one, it's already a product of something, right? So you don't need to factor because all of them, both of them are already in the factored form. So we have basically square root over another square root, right? Okay, so when you calculate a ratio between one square root over another square root, you can combine the two square roots, right? So what's left under the square root is here. Okay, And then you can try to cancel something. Okay, cancel an A here left us an A. Cancel a B here leaves us a B in the denominator. Cancel an C here leaves us a C in the numerator, right? So the result is 4AC over 5B, which normally we don't leave any radical signs in the denominator. So we can separate these two as this form, right? Okay, now times square root of 5b for both the denominator and the numerator, which is 2, 5abc, and the square root, okay, 5b here, right? This is the final result. Can you see why you made a mistake here? Hello? Any questions? Okay, the next one. Okay, next one, both the numerator and denominator in a factor form. That means the product, right? All of them are already in a product form. So now we can try to cancel something. Okay, we can note that xy is actually minus y. Oh, rewrite it here. You can't directly cancel these two terms, right? Because they're different. One is x minus y. Another one is y minus x. So note that x minus y is minus y minus x, right? So first of all, we need to change them to the same base. Okay, minus y is minus y minus x, right? This one to the fifth power over y over x to the third power. And then these two terms are the same. Now you can cancel, right? So, but before we cancel them, this one is 1 minus 1 to the fifth power, y minus x to the fifth power, and then y minus x to the third power, right? Okay, now we can simplify. This one can be simplified to this one, which leaves us only 2 power to the second power. Minus 1 to the fifth power is minus 1. So the final result is minus 4a to the third power times y minus x to the second power, right? Any questions? Oh, sorry, we can cancel an a here. Excuse me. We have a here, right? We can also cancel an a. So this should be 4a to the second power. Okay, any questions? And you should also note that x minus y to the second power is equal to y minus x to second power, right? Can you see why? Because x minus y to the second power is actually minus y minus x, this one to the second power, right? Which is minus 1 to the second power times y minus x to the second power, which is y minus x to the second power, right? So you can also write this result to this one. Both of them are equal. Both of them are right, okay? Any questions? Okay, no, if no questions, let's see the next one. Okay, first term divided by something. Okay, both of them are in a factored form already, right? So now let's see what we can do. Okay, first of all, let's rewrite the expression in a ratio form, which is y minus x to the second power. As we said that xy, the difference of y and x to the second power, which is actually x minus y to the second power, right? Because we have already proved this on the right-hand side. This is the reason, okay? We can rewrite the expression like this. Then we can cancel these two exponents, which leaves us a 2. So the final result is 3a squared times x minus y as a whole to the second power. Okay. Next one. As I said, you can't just cancel an a directly, right? Because they're not in a factored form. First of all, if you want to cancel something, it's better to write it like this form, in the product or in a factored form, and then you can try to cancel something, right? So first of all, let's factor each of the numerator and the denominator. So the first, for the numerator, try the cross product method, okay? 1a squared, 1 can be decomposed to 1 and 1. Okay, minus 5 can be factored to 5 and minus 1. Then 1 by 5 is 5, 1 by minus 1 is minus 1. The sum of these two numbers is 4. So 4 is equal to this one. So the numerator can be factored to a plus 5 times a minus 1, right? And remember, you can always verify your result by expand the expression. Okay, the second one is actually the formula of a plus b as a whole to the second power, which is a squared plus 2ab plus b squared, right? So we can write it like a plus 5 to the second power, right? And then we can try to cancel a plus 5 because they are already in a factored form, in a product form, okay? Actually, a plus 5 to the second power is, that means a plus 5 times a plus 5, right? Because something to the second power is something times same thing. So now we can cancel a plus 5, which gives us 1a minus 1 over a plus 5, right? Any questions? No? All right, let's see the next one. Okay, Next one, actually, we can directly cancel something, right? 12 is 3 by 4. A to the n plus 2 times is a to the nth times a to the 2th, right? It's the second, sorry. B to the m plus 2th power can be rewritten as b to the mth power times b to the second power, right? Okay. All of them are multiplication sign. Okay, for the denominator, 9 is 3 by 3, okay, times a to the nth times b to the 3 times b to the mth times. Actually, you don't need to write this. Write it like this, right? Because we can directly write it like, okay, a to the n plus 2th divided by n to the nth. A to the nth is a to the 2th, right? Okay. You can directly simplify it, actually. Okay. Okay, this leaves us a to the second time here. And when we cancel b to the mth power, this leaves us a b here and 1 here, right? And also 12 and 9 can be cancelled as 3, which leaves us 4 here, 3 here. So the final result is 4a squared over 3b. Okay, those of you, any questions? Any questions? No? Okay, next one. Okay, next one, minus minus. Okay, when you see this, first thing, for me, the first thing is to cancel these two signs, right? Because minus minus, you get positive. Okay, so first of all, both of them are in factored form. Okay, let's see what we can do here. Okay, a minus x in the numerator and x minus a in the denominator. So first of all, we can try to change them to the same x minus a, or to the same a minus x. I think it's easier to change it like a minus x to the 4th power, right? Because 4 is an even number, so x minus a to the 4th power equals a minus x to the 4th power. Okay, this leaves us we can try to cancel a 2 here, which leaves us a 2 and a 9 here, and cancel a minus x to the 3rd power here, which leaves us 2x over 9y a minus x, right? Any questions? No? Okay, next one. Next one, x minus 4 over x plus 3, right? Times the reciprocal of the second term, which is 2x minus 8, x squared minus 9. And then before you cancel something, rewrite all the terms in a factored form, which means a product of something. Okay. For the numerator, can be rewritten as x plus 3 times x minus 3. For the denominator, this can be rewritten as 2 times x minus 4, right? And now you can see that a minus 4 can be canceled with this one. X plus 3 can be canceled with this one. So what's left there is x minus 3 over 2. Okay, any questions? Really understand? Okay, next. Okay, next. Okay, according to the order of arithmetic operations, let's try to find the terms in the brackets first, okay? Apparently, this can be rewritten as these 3 terms, okay? Divided by something, we just keep it there. Okay, the least common denominator is AB, right? So we can rewrite these terms as AB A squared plus AB B squared plus AB 2AB. Okay, divided by something is times the reciprocal of this term. Okay, now these 3 terms can be combined together. AB A squared plus B squared plus A 2AB times A plus B, right? And now you can see that we're using the same formula here. A squared B squared 2AB is A plus B as a whole to the 2nd power times, sorry, let's write this term first. And this one times A over A plus B. Okay, actually, it doesn't matter if you put a brackets here, right? A plus B, you can see this as a whole. So now we can cancel an A here, and then an A plus B with this one, which leaves us A plus B over B, right? Any questions? Okay, next one. Again, follows the order of arithmetic operations. So that means we calculate the 2nd part first, okay? Just leave the first part there. The 2nd part is, okay, try to write each term in a factored form. This first one is 2 times A minus 1, and A squared minus 1, according to the formula, is A plus 1 times A minus 1. Okay, divided by A plus 2, A minus 2, sorry. A squared minus 2A plus 1 is A minus 1 squared, right? Okay, next step, 2A over A plus 1 minus 2 times A minus 2, A plus 1, A minus 1. Divided by something is times reciprocal of this term. Okay, and now you can see that all the terms in a factored form, and then you can cancel these terms, right? You can cancel the common factors there. Okay, there's a common factor A minus 1. A minus 1 can be canceled with this one. Okay, now this expression becomes 2A over A plus 1 minus what's left there is 2 times A minus 1 over A plus 1, right? Okay, now both of the terms are using the same common denominator, so we can just directly combine these two terms, which is a minus 1 as denominator. What's left in the numerator is 2a minus 2 times a minus 1, right? And then we can expand the numerator as 2a minus 2a. Remember, pay attention to the sign here, especially when you have a minus sign in front. Be very careful, okay? Be very careful with this. When you have a minus sign in front, pay attention to all the signs after the minus sign. So minus 2 times minus 1 is 2, right? So the final result is 2 over a plus 1. Okay, pay attention to the sign here. This is very important. All right, any questions? Any questions? No? All right, let's see the last question. Okay, let's try to calculate the first two terms first, because they are in the brackets, right? Okay, pay attention that both of the two denominators look very similar, right? Because x minus 5 is just minus 5 minus x, right? So first of all, do not just multiply them together. Do not use this one as their common denominator. Actually, their common denominator is x minus 5 or x 5 minus x. You can use either of this, right? I'll write it here for you. Okay, I'll write it in the right hand side. Okay, the least common denominator of x minus 5 and 5 minus x is x minus 5 or 5 minus x. You can use either of them, okay? You can use either of them. Not x minus 5 times 5 minus x. This is not necessary because it is not the least common denominator. It is a common denominator, of course, but it's not the least one, which may complicate your calculations thereafter. All right? So for example, if we use x minus 5, let's see what happened there. Okay, we use x minus 5. Then if we change the second term to something over x minus 5, that means we have to times minus 1 to both the numerator and denominator, right? Okay, and then divided by the last term. Okay, now we have x over x minus 5 minus x minus 5. So minus sign and minus sign becomes a plus sign, right? So our next step becomes x over x minus 5 plus x over x minus 5, right? Okay, now here we can change it to times the reciprocal of the last term, which is 2x here, x squared minus 25 here. Okay, so here we can add the first two terms because they are using the common denominator now, which becomes x minus 5, 2x, right? Okay, 2x here. X squared minus 25 can be rewritten as, according to the formula, x plus 5 times x minus 5, right? Okay, and last, we can cancel a 2x here with 2x here because all of the terms are now in a factored form. X minus 5 can be canceled with x minus 5, which leaves us only x plus 5. Understand? Okay, any questions? Both of you, any questions? No? Okay, if you have no questions, please correct these questions carefully, okay? And add necessary questions in your error book. Next time, for assignment 8, I'll assign similar problems to you, but I'll make the questions fewer, okay? In order you don't have enough time to do them. Okay, you can download the next assignment probably early tomorrow, okay, because it's already late tonight. Okay, then if you don't have any problems, you can leave the class. Okay, have a good night. Okay, do remember to check Google Classroom early tomorrow. Okay, bye-bye. Oh, yes, I'll post the edited work to Google Classroom. I'll do it now. No problem, I'll do it now. Teacher notes here. Okay. 好了。